Okay class, so today we're working on homework 5.8. This will be analyzing graphs of polynomials. A couple of things that they're asking for. You need to read the instructions to identify the X-Intercepts. That's where our graph crosses the X-axis. Local minimums and maximums. So we know minimums look like this. This is minimum. Maximums look like this. This is a maximum point. We're going to look for those local minimums and maximums. And then we want to talk about where the function is increasing or decreasing. So you have a function like this. It's going to be increasing from negative infinity until this point. Also, you have a local maximum here. It'll be decreasing until this point. You have a local minimum here. And then it'll be increasing all the way up here until positive infinity. So we'll talk about those intervals too. The first thing you want to do is to take this equation, g at x equals 2x cubed plus 8x squared minus 3, and put this right into your calculator. So you're going to go to the home screen. Then you will go to document. You want to add a new document. You want to add a graph. And then you'll be able to start typing in this. You're going to type in 2x cubed plus 8x squared minus 3. And what you get out actually looks very similar to this this cubic right here. And you can see that it crosses the axis 3 times. The x-axis was crossed over here, maybe at 1, 2, 3, -4, maybe at -0.5, and maybe at +0.5. We don't know, so we need to actually find those out. And to be able to find the x-intercepts, what you want to do is type in your calculator. You're going to go to menu, and then type in the number 6, and then type in the number 1, menu 61. And when you do that, you're going to click to the left and the right of your very first 0, okay, your very first x-intercept. That happens at -3.901. 0. That's your first 0 over here at -3.901. Let's go on to the next one. You're going to hit menu 61 again. That's menu, analyze, graph, and then 0. And click on the next time that the graph crosses the x-axis. This happens at -0.671, 0. Go to menu 61 again, and your last 0 happens at 0.573, 0. So now you've got your 3 x-intercepts, and you can go ahead and plot them over here on your graph. So come over to your graph, and the first one you're going to plot is -3.901. So we come over here, -3.9 is probably about right here. And then we'll also go to -0.6, and then +0.5. These roots are all crosses, and we'll talk a little bit about that here in just one second, what that means. Alright, so we have our x-intercept labeled here. The next thing they want us to do, of course, is talk about local minimums and maximums. And so you can tell that this is a local maximum. It's the highest point in this area. And over here is a local minimum. It's the lowest point over in this area. So we're going to have the calculator calculate that for us. Alright, so for your maximum, I actually had to adjust my Windows settings, and you can do the same thing by manipulating your your y-axis. Okay, once you get to this point right here, you're going to want to press menu, and then you want to actually analyze the graph. So again with the 6. And instead of going to the 0, you want to see the maximum. The maximum is option 3. So menu 63 will get you to a maximum. Again, you just tell it the left and the right of the maximum. And that happens at -2.667, 15.963. There's your local maximum. We have one more down here. It's a local minimum. And you're going to do the same thing this time. Menu, 60, and now choose 2. And that will bring up your local minimum. That happens at 0, negative 3. Okay. So here are your minimums and maximums. Here's your local minimum and local maximum. They scale our graph for us all the way up to 18. So I know that this maximum can fit. We just need to make sure that we use the coordinate point correctly. Negative 2.667 is about right here, and then we're going to go up to 15.9 is almost 16. Negative 2.667. Okay, so that's about right here for your local maximum. And your local minimum happens at 0, negative 3, which is right here. So that's dotted in. And now we're going to talk about intervals of increasing and decreasing. So let's sketch our graph real quick. We're going to cross the axis here. We're going to have our maximum here. Cross the axis again here. Have our minimum here. And cross the axis again. Go ahead and draw your arrow markings. And we'll get set up for the next one. Okay. So the next thing they asked us to do is just talk about increasing or decreasing. This is a review from our last chapters again. You can tell that this section right here is where your function is increasing. Okay? And it's decreasing here, and it's increasing here. So we just need to write out the red intervals, and then we'll write out this one black interval in the center. We said the red intervals was where it was increasing. So the function is increasing from negative infinity. See out here we're at negative infinity. All the way up to negative 2.667. I'm using that coordinate point because that's my maximum right here. Negative 2.667 is this coordinate point right here, that x value. Negative 2.667. So we write that negative 2.667 over here. Then the function is decreasing in this black area, and this is negative 2.667 all the way down to where my x value is here for my next minimum. That's over at 0. Okay, so it's decreasing between negative 2.667 and 0. And now it is increasing again on this red interval that you see here, and that's going to be from 0 all the way, this arrow marking tells you, positive infinity. So from 0 all the way to positive infinity, it's increasing. Like that. From 0 to positive infinity. And now we can just make sure that we have the chain correct. And you'll see a chain that goes from negative infinity all the way to positive infinity. So negative infinity to negative 2.667, negative 2.667 to 0, 0 to infinity. So you've been able to describe the entire function from negative infinity to positive infinity, telling me where it's going up and where it's going down. Again, where it's increasing and where it's decreasing. Okay. Now that problem's done, and we're ready to move on to the next one. The next example goes a whole lot faster. They tell you where the X-intercepts are already, so we don't have to bother finding them. They also tell us a local minimum and maximum value. And when they do that, they actually don't tell us anything about the Y, so we really don't care about that. We just want to dot these in on our axis over here. So let's take a look at that. We're going to start, we need to go from negative 4 on the X side to positive 2 on the X side, so I can go out negative 1, 2, 3, and 4, and positive 1, 2, 3, and 4. And then, now that you've got that done, you just want to dot in all of your coordinate points here. So x equals negative 4, that's one of them. X equals 0, that's another one. X equals 2, that's another one. Okay, so there are my x-intercepts, and then we also know that there is a local maximum when x equals 1. So somewhere up here, right, it'll be a maximum like that. And then we're going to have a minimum, a very small value down here at x equals negative 2. So probably something more like that. Alright. So for this to be true, for all of this to actually happen, we can't just start here, right, and come up and then come down, because that would create another maximum. So what you want to do is kind of figure out, how does this graph need to go to make all of this true and connect the dots? So go from left to right and connect all of the dots. You're going to cross at your root there. You've got a local minimum. Cross again at your root. Hit your maximum and then come down. Alright. So now this function is actually really strange because it does not look like our normal cubic over here. You see y equals 2x cubed. In this cubic, it starts low and it ends high, but over here it starts high and it ends low. So the parent function for this, y equals x cubed, must have been reflected. This is a reflection that's going on here from this parent function up here. Alright, last one is number 48. Let's take a look. So during a recent time, the number S in thousands of students enrolled in public school in a country can be modeled by this function. X is the time in years. Use the graphing calculator to the function 0 between 0 and 41 on the x-axis, and then describe how the public school enrollment changes over this time. So this is actually a much easier question than it looks, because they actually say don't look at the whole graph, just look at this one little window. So it's much more specific and much easier to look at on your graph. So let's start with our window first. Make your map. So come underneath here, draw a 4x4 box, and then take a look at your two variables. You've got the x variable in here and the s variable over here. So just like a coordinate point xy, we're going to write x and s. Your x variable, they tell you the number, the time in years. So that goes time in years. And then over here, s is going to be number of students in thousands. So number of students in thousands. And they are saying the x variable is going to be between 0 and 41. So all they want us to do is actually just look on our graphing calculator between 0 and 41. Let's check that out. So when you're on the Inspire, the first thing you're going to do is go to the home screen. You're going to click on New Document, and then you want to click on Add a Graph. The graph you're going to add is just this function that they have written here. So just type in 1.64 x cubed, and then minus 102 x squared plus 1710x and then plus 36,300. Okay. So when you hit enter, the first thing that you see is that this actually, you can't see anything on the graph. There's nothing that comes up, which is actually good news for us because we need to mess with the x-axis anyways. So what you're going to do is go to Menu. You want to go to Windows Zoom. This is option 4. And then option 1, which is Windows Settings. The first thing that you see when it comes up is your X-min and your X-max. It's set at -10 and +10, but you don't need to use that. What you need to use is 0 and 41. Now I like to back this number and this number out just one. So I'm going to actually use -1 and 42, just so I can see more of the graph. I'm going to say -1 for X-min, and then 42 for X-max. I can leave everything else exactly the same as it is right now. Again, because I can't see my graph right now, I know that the y-axis is probably messed up too. So I'm going to go to a y minimum of probably -20, and I'm going to try y maximum at +20 and see what happens. Again, my x minimum